putting up, in the near future, by putting up a network of balloons into the stratosphere, much higher than where the weather is, much higher than where airplanes fly. So you can see, you can think of each of these balloons as being sort of like a cell tower in the sky. It can talk to the phones on the ground and to the other balloons around it. It turns out that this is so high, you can't tie the balloons to the ground. And the winds are high enough, there just isn't enough energy up there that you can actually fight the wind to stay in one place for a long period of time. But we've found ways that the balloons can rise and fall about 10,000 feet total. And by rising and falling, they can choose different winds that go in different directions and at different speeds. And that allows them to sail to some extent, and in that way, to have some influence over where they'll be in an hour or in a day. But at the beginning, we couldn't make them go anywhere. We were just starting out. And we couldn't tell them when to come down, which we now can do also. We were working on the basic avionics, which doesn't sound like that much until you realize that we were trying to make a cell tower that was 1% of the weight at 1% of the cost, used 1% of the power. It had to work at 2% of atmospheric air pressure and at temperatures to 90 degrees below zero. So that was enough to work on at first, just to see if we could fail doing that stuff. But what we really didn't want to have happen was for these experiments of ours to drift into some country whose permission we had not yet asked. So we designed our early balloons to fail. We don't do this now, but our very first balloons were made out of latex. And they have this awesome principle that guarantees that they'll fail. You put some helium in the balloon, and the balloon starts to rise. And as it rises, because the air up a little bit is less dense, it expands, it stretches, because latex is stretching. But when it stretches, its density is less, so it rises some more. And this cycle continues, it just keeps going up until it's at 100,000 feet or so, where it's so thin and so brittle from the cold that it explodes. So these, and this is actually a picture of the moment of it exploding. So being able to know that the failures we had baked into the system would be a safety valve for us so that we could work on other parts of the project was a nice mantra for us early on about the value of failing.